Can you guys hear me? Yep, I guess. First of all, I would like to thank you all for being here. I know it was a really long walk all the way to this room in the end of the Black Hat, so thank you for that. So this talk, this is a presentation that has multiple presentations inside. There's like many layers of things that you will learn that you can do with BMCs, and I don't want you to get out the talk with just the idea of exploits. Exploits, to be honest, is the less important thing on this presentation. So if there's something that I want to transmit on this presentation is that don't concentrate on the exploit, even though they're like remote code execution, authenticating, all the cool things. That's not an important part of the presentation, but rather the multiple things that you will be able to see and do with BMC. Anyways, I guess everyone works on computer here, and if you ever work in computer and you have an elder in your family, I'm sure they will at some point contact you and ask you for help for one of your problems that they have in the computer. So, I mean, I want to do this a little bit interactive. So what will be the one and only solution for pretty much all the problems in computers? Raise your hand. What you said? Restart, exactly. So obviously, restart is mainly the solution to 99.99% of all the problems on computers. So what happened when those problems happen on data centers, right? As you can see in the screen, there's a lot of servers there. Some of them are screaming to be rebooted, and obviously someone has to go and actually press that button. And I don't know if you have ever been in a co-location. I have been into one, because I don't know if you know, but we were recently bought by a co-location company, so now we really love co-locations, but we don't love to be there. And I'm sure everyone that has been here hate to go to co-locations. And I mean, you love to have your servers there, but you hate to go personally there. And there are many reasons for that. And the main reason you can see in this picture, do you see a chair there? I don't. And that's one of the problems with co-location. You end up working standing. Probably the only person that can, or not a person, but the animal that can be sitting down will be a dog or your animal. I don't know what kind of co-location allow dogs in, but I would really want to know. Definitely not ours. So the other problem with co-location is like super cold. So everyone really, when they go to co-locations, are like, wearing like multiple layers of clothes, and everyone's unhappy in co-locations because you have to drive like 45 minutes to your next co-location. And you'll be looking at this picture and be like, well, this dude actually look happy. And the reason they look happy is because they already fixed their problems and they know they're going back home. But there's only one dude that is not happy. And you know why he's not happy? He's not happy because he's the one that lives closer to the co-location. So he knows that as soon as everyone returns, it's going to be back. And one server is going to crash, and he's going to be the only one going back to the co-location. And this dude has to go all the way from my wedding to the co-location, because that's how it works when you work in IT and you're on alert. Anyways, most important slide of this presentation, who we are. My name is Nico Weisman. I'm a VP at Immunity. My name is Matthias. I also work at Immunity as a security researcher. BMCs. I hope I will be able to say exactly what it means. It's baseband management controller. Is that correct?
Yep.
Yeah.
Baseband.
BMCs. BMCs are this interesting device that works completely independent from the OS, and you will find it in like big servers. And they're interesting because they allow you to remote control the server, and they're kind of isolated self from the server. They can connect and do many things, but they're a completely different device from the server itself. And it's super interesting because basically the BMCs are the answer to IT people being like, I don't want to drive to the co-location. So they come up with an idea to allow them to monitor the temperature, the voltage, the fans. And as you can see in this graph from one of the many vendors that put together BMCs, there's a lot of really interesting information. You can pinpoint exactly the temperature at different parts of the chassis of a server. So in reality, they are super interesting. However, as I explained, they're basically a machine inside a machine. So it has a lot of different really cool features, like it has a full network stack inside the little device. It has KVM, so it's keyboard, video, and mouse. It has a direct serial console to the server, and obviously you can do power management. Basically, you can reboot. But obviously you want that because you don't want to be at the co-locations. You want to remotely connect to the BMC, and from that point manage the server when the server crashes and there is no way to remotely connect to your server. However, if you think about it, it's kind of like the perfect backdoor, right? It's like you can remotely connect to the machine, you can reboot it, you can manage the keyboard, the video, the mouse, but there's always someone in the crowd who will be like, this is not the perfect backdoor, because if the server is down, the backdoor is down. However, let me tell you something. The interesting thing about BMCs is that no matter if there's electricity going to the server, the BMC will be on, which makes sense though. But if the server is down, the BMC can still be on. And keep that in mind, because as we continue talking about the different things you will be able to do with a BMC once you compromise it, this feature is quite interesting.
So IPMI stands for Intelligent Platform Management Interface, whatever. But it is basically a set of standards and conventions that were put together in order to define how these remote management devices should work and how the different components should work together. So the main component here is the BMC that Nico was talking about, which is in the end just a small computer in there that has a microprocessor, memory, storage space. It's actually running an operating system in there. This device has multiple connections to different ports, and it's able to access different devices on the chassis, on the server. So for example, it will have access via a port which is called IPMB, yeah, and it is a variant of I2C. Via this port, it will be able to access the fan sensors to get the speed, and the temperature sensors, and all sorts of stuff to be able to monitor the server. But these devices also have an Ethernet card. Usually they have a standalone card for themselves so that you can actually access them or get to the web console or whatever. Some other times, instead of that, what they have is they have what is called side channel access to the main network interface from the host. So they are able to tell that interface, hey, these packets, please send them to me. Basically, you can configure a couple of filters to see what packages go to the host and which ones go to the BMC. This device, the BMC also has connections to the power supply unit on the server, so it can power on or off the server or monitor the power consumption. And most interesting is that they usually are connected to one of the main buses of the server, such as PCI or PCI Express, for example. So each of the main vendors on the market have their own implementation of this, their own variant. They all offer similar features to the administrators, but they have some differences. So for example, you have Dell with iDRAC, HP has ILO in different versions, 2, 4, and 1 also, and Lenovo has IMM. So let's see a little bit the differences between each other. When you go to HP ILO 2, this is built around a microprocessor which is called NEC B850. So this is a very old processor that was originally used in optical drives and hard disks. So you can imagine that having that processor running a real OS is kind of slow, right? Speaking of the OS, these things run an operating system called ThreadX. Apparently this OS was, this is a real-time OS, and it was pretty well known on the embedded device world back in the times. But honestly, the first time I saw it was when we did this research. From the reversing standpoint of view, when you unpack the binary, what you end up with is just one huge binary, one huge thing that you can load into IDA or whatever. But in there, you have like all the functions that handle everything, like all the for handling the web server, the IPMI server, the SSH server, like everything is one big thing. On the bright side, the assembly for this processor is very nice. So after a couple of hours you are working with it, you get used to the syntax, and it's very, very easy to understand. This is 32-bit RISC.
We heard rumors that there's some source code in the internet. We were not able to access it, but we heard that there's some Chinese website somewhere.
So yeah, all of these OSs are closed source. When we moved to ILO 4, so we were working a couple of weeks with ILO 2 and then we moved to ILO 4. We actually were expecting to be able to reuse like everything that we have learned in the previous weeks while working with these devices. But the truth is that didn't work very well because HP decided to redesign the whole thing when they moved to ILO 4. So they are now using ARM, which is good because now ARM is pretty good, well-known processor. There's a lot of information, examples on the internet or whatever, tools, everybody supports it. But it's ARM, right? You have to read ARM assembly, and that's like really, really bad. Regarding the OS, they are now using one that is called the GHS Integrity. It's also a real-time OS built by the same companies before, so things that are similar. What's good is that when we moved to iDRAC from Dell, in this case, well, they're using a processor that's called Super H. Does it ring a bell for anybody here? Super H? Yeah, I bet you are gamers, right? No? That was used in the console called
Sega Saturn.
The Sega Saturn console back in the 90s, in the days. But the good thing about iDRAC is that it's Linux-based. So for us, trying to understand how this thing works, that's really good because you end up analyzing a known file system, known tools, known services, configuration files. If you want to reverse or analyze a specific service, you can grab that binary by itself and load it into IDA, and you don't have to deal with the whole thing. So this one is much more easier to work with.
So when we did this research, we were like very limited scope, and we have a lot of different things to cover. So what we decided to do is to concentrate on the most fruitful vulnerabilities. So we decided to go for, it's not an easy task, of course, but to go for like pre-authentication, if possible, remote code execution kind of vulnerabilities. There are like multiple things you can do, like man in the middle, post out things, which are, it sounds like it's not, but they are useful, as we learn later on the research. However, for example, most of these devices run on an out-of-band network, and man in the middle might be helpful, but not really, to be honest. You have to already be in that network, and that's like a big step. So we decided to go pre-auth. And when we start auditing this thing, one of the things we realized is that it's very exciting to do it. I don't think the audio is gonna work, but I'm gonna try. No, it sounds like, and that's like for hours and hours, because I don't know if you ever audit anything. You spend like hours and hours trying things. And the other thing is some of the things are super old. Like when we start auditing ILO 2, you have to install like very old Firefox just to be able to deal with the old certificates.
Yeah, the SSL was totally broken and you couldn't use any more in browsers to access it. It's like a pain. You had to install a VM just to be able to access that thing.
Just to, yeah. So
and then it's like super slow.
It was horrible. So the attack surface. So as I said before, we have 3 or actually 4 different targets, and we only have a certain amount of time. So what we thought we would do is try to decide which will be the better protocols that we could use, and then translate that into the different devices that we can use. So we thought, let's put together a list, and then and write fasters and audit and understand the protocol. So then when we move from one to the other, it will be super easy to do. One of the things you start learning is that even though it sounds that they share a lot of different protocols, in reality, when you start looking at them, everyone does what they want. Like they look like they are the similar protocols, but when you start like digging a little bit more, like some of the stuff are really, really different from each other. And it's kind of weird because like this is a thing that you eventually want to automatize. You want to be able to control multiple servers at the same time. So if they're from different brands, some of the protocol will really, really make your life miserable. So the first one we look at it was the Smash, which is basically a command line standardized by this organization called DTMS, which has nothing to do with phones. And this is basically a command line that runs over SSH. So we were thinking, if you attack this, the main problem is that you have to go to SSH. And we know that SSH has a lot of vulnerabilities. However, that was a long time ago. And the problem with that is that do we want to spend that amount of time finding new things or probably auditing open source library, which is what most people do. So we decided a little bit against it. However, later during the research, we find out that Smash could be a really good thing to start finding logic command injection bugs to obtain post-out access to the operating system. So this is a command line that doesn't give you a shell or allow you to execute anything at all. It's just like their own implementation of like monitoring through SSH. So if you're able to access that and get to the operating system, then it will allow you to debug better vulnerabilities that I'm sure you will find remotely. So I mean, it's a good type of post out, but pre out, which is what we're looking for, it didn't work as. The interesting thing is that as anything, and you will see all the different monitors protocol, everything allows you to do a remote console serial. As you can see, over SSH, you can access the BIOS and do like many things remotely. So it's kind of useful once you have accounts. And the people from Rapid7 in a couple of years ago put together a list of different default username and password. And that's kind of useful, especially because if you are looking on an internal network or external network, like the main two things that will be open will be SSH and 80 on these devices. So, and you will see a lot of default username and passwords because people really don't care about BMCs.
Then you have SNMP. I guess you don't need too much introduction to SNMP. If you scan, you will find a lot of devices with default public community, but that's not really very important. What we found that it's quite interesting is that if you unpack the firmware, you can get the MIB files. So then if you use a tool such as SMP Walk or something like that, you can query the devices for which you already know somehow the community string, even if the device is yours, and you can gain a lot of information. And some of the information, in this case, the one on the screen, I think it's a Dell, an iDRAC. What you're seeing there is a process listing with all the processes running on the system and the arguments. You might think this is not a big deal, but actually, even if you own the device, even if you have paid for it, the vendors won't give you a shell in there to be able to analyze or to do a PS or something like that. So just for us, at least, to be able to analyze and see what's going on, this is very, very useful. And also, the last time we checked on the devices that we were analyzing, they were all vulnerable to CVE from 2015. This is an initialized pointer issue. So it's not easy to exploit. You will have to deal with the heap and play, but it's not impossible to exploit. It's just waiting there for somebody to just write it.
But we want our own thing.
Yeah.
So EPMI, who heard about EPMI, aside from this slide that Matthias used? So it's really confusing because there is an IPMI protocol, but some people call BMCs IPMI, and there are like many things called APMI, which was a mess when we were like researching this. But there's an infamous protocol that all of the BMCs support. Luckily not by default anymore. However, you still see a lot of them online. And this protocol is UDP and runs on port 623. It's basically used like every other protocol on BMCs allow you to manage the BMC remotely over UDP. So you can get like a serial console or a UDP, which is useful somehow. The thing with UDP is that it was called in 2013 one of the most dangerous protocols in the world, and that's a bold statement because there are like really crappy protocols, and I'm sure you guys experienced some of those crappy protocols, which I'm not going to mention, but some of them were written by Microsoft. There was a really amazing research, and if you can just Google that, it was done by Dan Farmer on APMI. And again, if you're doing a pen test and you see that port, you should be really happy of what's going to happen to you. So the first thing that APMI did in one of the earliest versions is they came out with this different method to authenticate. One of them was called Cipher Zero. So when you see that name, you're like, something's wrong here. So basically, if the API allows Cipher Zero, that means that they require no username or password. So that pretty much ends the research. However, no one supports Cipher Zero nowadays, thanks to Dan Farmer. However, Dan found a really interesting vulnerability, which is the famous RACP authentication debacle. And there's a lot to talk about this, but I'm going to try to be brief. Basically, there was a 1.5 version of this authentication mechanism that was using MD5. So I guess that's my own interpretation of the thing. I guess they were like, MD5 is normal, so let's move into something like HMAC, like a more complex encryption hash, sorry. And so they put together the version 2.0, which does a really interesting handshake. Have you ever heard about this vulnerability? Yeah, so basically what they did is like this handshake, like sending a couple, I think you have to say 4 or 6 packets to do the handshake between the server and client. If you, at some point, you send the username you want to log in, and they return the hash of the password. Like the server, you say like, I want to log in as an admin, and the server is like, this is the hash of the password. And you're like, why they will do that? And you know what the more interesting thing is that was part of the design, so they are not able to fix it, because there is no fix. This is how the protocol works. And so nowadays, if you see an API, this is the last like modern authentication mechanism on RACP. So if you see an API online or internal network, that means that you were able to obtain the hash of any username. So kind of like the username is a password, because you have to put like a really complex password so like people doesn't guess it, I guess. Anyways, then finally another vulnerability that the guys from MWR did was they find out that the session ID being used after authentication, remember this is UDP, it was kind of predictable. There's like out of the 4 bytes, there were 2 that were fixed, and then the other ones easy to predict. So obviously you can inject packets in the middle. If you're like in a position to inject packets, it's easy to guess it. So remember, this is UDP. You can have a serial console with UDP, so it's kind of like bad. We look at it and we're like, this is almost done. But we want to look at it anyway, and we find a really stupid bug. So this kind of like integer underflow is super easy to see. Obviously, this is pseudocode. So basically, there was a message land on the main header of the API package. That's like the one that encapsulates all the other things. So there is not even like authentication at this point. And if you make it less than 6 bytes on the allo2, this is going to become a negative number. So then then there's going to be an overflow on the pool that's being allocated, which is a fixed site. And this is a trigger if you want to try it at home. It's not easy to exploit, but it's doable. But again, there's going to be better things. So, sorry. Other of the targets that we were looking at were web servers, right? Because web servers are always really interesting. And at least in the case of BMCs, they're also interesting because on our experience, every time we were working on like big networks for clients, we always, even if these devices were like in isolated networks separated from the rest, port 443 or 22 for SSH was always open. I don't know why. Maybe because admins use this port to get to the BMCs or whatever. So that makes it actually a more realistic scenario for an attacker to be able to reach that port that may be some other weird thing. Most of the devices that we analyzed were using a web server, which is called APP Web. This is pretty popular on the embedded world, and is kind of very secure, very well audited, very solid. So finding a bug in there can be done, but it would have been a challenge. But the thing is that sometimes vendors decide to not use the proven solution that they know that works and it is secure and everything, because they can just build their own thing, because why not? So some of them decide to build their own web servers. And there's when things get really interesting.
But also, speaking about web servers, it's not only about the web server themselves, but also about what web servers give you access to, what kind of things are built on top of web servers. So what you see on the screen, for example, in the case of HP ILO 2, HP ILO in general, they have an endpoint that is called XML data that is reachable unauthenticated. So if you just point your browser there, the device will spit out at you a lot of information in XML. And in that information, you will see, for example, the IP addresses and MAC addresses, but also you will find the exact firmware version. And if you have ever been working or trying to exploit a device or having to develop an exploit or something like that, you know that knowing the exact version of the system that you are targeting is very, very useful. It's actually invaluable. In the case of iDRAC, it has something similar, just with a different name. Both of these features can be disabled. But at least again, in the cases that we have seen in companies, administrators don't want to disable this because they actually use it. And there is no way to enable authentication. You either have it there, like accessible to everybody, or you don't. Okay, so continuing with web servers, there's a very, very interesting bug that the French guys, let me read their names properly, Fabien Perigard, Alexandre Gasset, and Geoffrey Cizorny. There's a very, very amazing bug that they found. It's actually, so the ILO 4 web server, when it parses an HTTP request, it checks for the different headers, and when it finds the connection header, it will use SSCANF without any kind of size validation at all to read the content of that header. And the value is actually stored on the stack on a buffer that was like 14, 16 bytes around those numbers, more or less. So this is just a plain stack overflow. You can just, like that, with sending just one request, you can crash the server. But what is much more interesting is the actual exploit that they come up with, which is very, very clever. Instead of doing the classic shellcode thing and trying to get code execution, what they found was that there was a variable in the stack a little bit below the one that was being overflowed. And that variable was actually a flag that indicated if the connection was remote or local. So local is from the same from the server where the BMC is attached to, and remote is from the network. And whenever a connection is local, it doesn't need authentication. So in the end, what you can do is just send a request, an HTTP post, for example, with this specific header with a size of 29, with whatever value you want, and that will trick the web server into thinking that the connection is local, so it doesn't need authentication. So that request will just go through. And what you see there on the screen is the request that you need to send to create a new user on the system. When we analyzed iDRAC 8, we also found another vulnerability that reminds us to the 90s again, because this is like the kind of thing that it should happen anymore. And in this case, it was a remote environment variable injection. So basically, the problem here is that the iDRAC 8 web server, what it does, when it gets a request that is directed to the /CGI bin path, it will call a handler, and this handler will do basically 3 steps. First, it will try to find the binary that needs to be executed. Then, as a second step, it will parse the URI and use all of that parameters in order to build the environment for that binary. And then it will finally execute it. And there are a couple of binaries that are available unauthenticated, such as, for example, login that needs to be available authenticated, right? So what you can do is just send a request in there, and for that binary that is being executed, you can control all of the environment variables.
How will you exploit that? Is there anyone from the 90s that you used to see this kind of bugs? Do you remember how you exploit that?
So you can control all the environment variables for a binary that you are executing on a remote system.
It was a common trick that we used to do, people long time ago, I guess, when you find this kind of bind. No, yes. Obviously the LPRO is for sure. But I mean, how do you, which DLL will you load? Well,
so basically, yeah, if you send any environment variable on the URI that will be sent to the binaries executed. So if you send LD debug, the web server will throw at you all the debug. The linker will send you all the debug information for the libraries loaded. If you send, you can also send LD preload, as you well said, and that will instruct the linker to load a binary. But that binary that we can somehow try to put something up that we can control should be on the same device where this web server is running, and that's the BMC, and we can't write files to the BMC, at least not yet. So the old trick that was done, this was done like a million times before to exploit these kind of things, was to point LD preload to the standard input file for the self process. So if you did that, you can send your payload, your shared library with your code on the same request that you were doing to a web server. But unfortunately, this didn't work very well for us because somehow the linker on this device didn't like non-regular files. So this actually didn't work. mmap was failing there. So we kept looking to trying to find a different alternative for this. And what we found was a different primitive that's also actually a CGI that will let you write to a specific file that you don't control the name, that is fixed /tmp/something, but you can control the whole data in that file. So then it's game over, right? Because what you can do is first use this primitive to upload some content to a file on the BMC, where you will upload your connect back, for example, as a shared library. Then as a second step, you will use you will do the trigger with the LD preload thing and finally get your connect back. So let's see a quick demo of this in action.
Again, this is remote. This is a logic bug. This is unauthenticated. It's like, and this is a bug from the 90s. Like who uses GGI bean and allows environmental variables?
Okay, so can you see there? Yeah, that's okay. For this demo, we are using Canvas, that is our exploitation framework for penetration testing. The exploit is actually very easy to use. You just need to know the IP address and the port where the BMC web server is running, and just click OK. So this will actually do the two steps that we tell you before. First, it will do this trigger to upload some content to a known file. Then as a second step, it will actually do the trigger with the LD preload to force the linker into loading that code. So in Canvas, we have the concept of nodes. So each of those circles that you see in there represent a host where we control, we can execute commands, basically. The first one that was already there when we started the demo represents the machine where we are running the software. And the second one that then pop up, that represents the device that we have just compromised. In this case, is the iTrack. So that little window that lets you interact with the node. So as you can see, once the exploit works, basically what we end up with is with a shell in there where you can execute commands, get like the host name or whatever, and as expected, always guess with what username the web server is running. Because why not, right? Okay, so.
Just in case you notice, we were attacking localhost. That's not because the BMC was in the localhost, but rather we have a tunnel to our labs, which was in a different office. So that's why we were attacking localhost.
Okay, I don't know why it went again to the beginning.
Oh, here we go.
Crap.
Let's start again.
So,
I'm sure Bob will be happy.
Whoa.
That's you. Okay. All right. So I think I'm missing some slides. Oh, here we go. Okay. WSMan, this is a protocol that definitely we're missing slides.
Yeah, that is weird.
Yeah, because you're in the wrong slides. Matthias, what happened?
Really?
Yes.
Oh, crap.
Sorry about that. Here we go. Yeah. Yes, we are using Google Slides. Crazy, right? But it actually works really well. Here we go. So WSMan, it's a protocol called Web Service Management. It has nothing to do with my last name. And Microsoft support this natively through WinRM. So it's kind of use it quite a lot because every Windows IT person can easily use it. It's supported by PowerShell, so that makes scripting super easy to do. And it's kind of a protocol that looks like XML kind of product syntax based on SOAP. How do you access it? In generally, it's another endpoint on HTTPS. It goes on the WSMan/WSMan endpoint. But also it can be found standalone running on the port 5985. And in general, it uses authentication, basically dishes out whatever authentication you had on the web server. However, in this case, to access at least the parser, there's no authentication at all. And the reason we put that picture, even though we already spoiled the bugs through that slice error, is that when we start researching things, you kind of like feel like using a fanny pack because like every vulnerability looks like the 90s. It's so weird. So the first bug we found was a bug while parsing the XML tag, super easy to find. And again, it's really similar to the vulnerability that the guys, the French guys found on ALO4, which is basically a scanf and on a stack buffer, a fixed stack buffer, super easy. And again, this is remote, this is unauthenticated, and it's there. In order to exploit it, it's super simple. We put the POG in case you want to test it. But again, this is sending some beats on the XML, and you just crash it. The other one that we found was kind of similar, but in a different place. It's on the what is called the name XML namespace, and again, the same kind of thing as scanf, Stack Overflow, unauthenticated. Yeah, same thing. Easy to exploit again.
So everything so far is quite nice. We have like, I don't know, 5 different ways in which you can compromise a BMC. But when you start thinking about real life scenarios, things are not so easy, right? Because while sometimes BMC are advertised as if you could just connect them to the internet, and that will make your life super easy because you can just reboot the server from wherever you are. The truth is that this is not what happens actually at least on big companies. Mainly when you go to some kind of big corporation, you won't find the BMC connected to the internet directly. In fact, what you will find is like one DMC where they will have the servers with exposed services to the internet or multiple DMCs. Then you will see a lot of different networks for internal services or backend services. And most of them will be totally isolated with each other or heavily restricted with what can be accessed from the other. And then you will very likely see some kind of totally different network on a different level, which is usually called the out-of-band network or management network.
This is kind of the perfect scenario. However, like in the last 3 pen tests that we did, we compromised like 2 domain controllers to BMC being accessible in the local network.
Yeah, they were like in the same network.
This is how it looks like, supposed to look like, but when you actually go to real companies, it's not really like that.
Well, in the best scenario, like what you should find in theory should be this. And the problem is that how do you use all what you have been seeing so far in that scenario, right? It's like you can't reach the BMC from the internet, so then it's not dangerous. We'd immediately like to talk about dimensions instead of networks because it's just a little bit broader of a concept. So think of a subnetwork as a dimension, but also a thumb drive that is moving data from one computer to the other, like a Stuxnet did. That could be also considered a dimension. So what we will see next is how to abuse the things that we have already seen and the inner trust that exists between the BMC and the host where this BMC is attached to in order to move between different dimensions of corporate networks. So let's start with what is already very known, Let's say that we somehow have access to the out-of-band network, that we are already there, right? Like on the hacker movies that they put a Raspberry Pi in the network, whatever. In that scenario, we know that we can compromise the BMC. I mean, we found a couple of vulnerabilities. The front guys found another bunch of vulnerabilities. And I bet that anyone who spends some time in there will already find a lot more. And from there, we can easily jump to the server. That is already kind of a known fact, because if you think about it, once you have compromised the BMC, it's almost as having physical access to the server, because you can control many things of the server. You can access the serial console. You can try to mount a remote device, a remote optical drive, for example. You can upload an ISO to the BMC, and this will emulate an optical drive to the server. You have also KVM, so you can manage the keyboard and see what's going on the screen, so you can reboot to the BIOS, for example. And there's also DMA. I recommend seeing the talk from the French guys from Recon on this topic. So if it has DMA, you can basically access the main server memory directly from the BMC. So let's see a quick demo of one of the simplest ways to do this. We decided here to go to the easy way, just to show you that it's possible. So we start by the assumption that we already have access to a BMC, that actually there is the web console for an iDRAC. Whoops, sorry. So what we just launched is the feature that's called Remote Console, what runs using Java, that gives you basically a remote KVM, right, with some other features. So one of the easiest ways to compromise this is, I bet that you have done this at least 2 times in your life. Whenever you forgot the password for your Linux, what did you do? How do you recover it? Mm-hmm. You reboot to the bootloader, right? If you don't have this encryption, you just boot to the bootloader. So the same exact thing can be done here. You can reboot to the bootloader, use the init equals to shell, and you will get root access to the server. This is a very, very naive example. We know that, but it works unless there is some like kind of disk encryption or BIOS password or whatever. But this is the easy way. You can always use DMA to try to compromise the server and be much more resilient and make less noise, because this will very likely throw a lot of alerts if the server is being monitored.
Very nice.
Okay, you could also try to mount, for example, a live CD image for any Linux thing, if this was a Windows, the host, and then using that, you can reboot to that live CD and mount the disks. So if you saw at the end of the video, we actually ended with root there. Yeah, okay. So, but that's just to prove the point that this can be done. Okay, so, but the thing is that, and this is not very well known, the problem is that the other way around is also true. Let's say that you have a server on a DMZ exposed to the internet. That's pretty usual. And that server gets compromised. The attacker can, from that server, jump to the BMC. And then we have a problem, right? Because as you have already guessed or heard the last half an hour, devices connected to these networks are very insecure. They are not built with the same security measures that any kind of thing that is being thought to be connected to the internet. In fact, if you read the documentation from all of the main vendors, they tell you that you can't connect these devices to risky networks. You have to have them in controlled environments. But if this is true, if we can jump from the server to the BMC, then we have a problem here. Because now I can access the out-of-band network of your company. So let's think, how is this even possible? There are a couple of things that make this possible. Vendors provide administrators with a lot of tools to be able to administer these BMCs. And many of these tools can be used either remotely from the network, via IP, for example, or locally from the same server where the BMC is attached to. And some of the things that you can do with those tools is, for example, create new users on the system or flash a new firmware. And some others have, for example, features to enable some kind of networking between the BMC and the server. But the problem,
definitely my fault, because I want to really show how important this slide is. So like that thing shows importance. It's like a dancing banana. But this is really important because this is a game changer. This is the, by design, vendors decide that the server should be able to do whatever they want on a BMC.
So whenever you use these commands, these tools from the server, there's no authentication.
And this is this is the trick that the French guys did on the ILO that Matthias explained. The reason why there was a flag that mentioned local or remote was that because local for them is like no access.
So they assume by default that if you have administrative rights on the server, then you should be able to have administrative rights on the BMC. But no one thought about the security implications that this have. So let's see a quick demo of, not so quick, on how this works.
5 minutes quick.
Whoa. Okay, so what we will do is, let me go to the slides. We will start under the assumption that we have already compromised a server on a DMC, right? We have compromised a PHP, whatever. We got code execution there, and then we were able to elevate privileges to root. So that is in the initial position where we are. Let's say that we are the attacker. One of the first thing that you can do is try to see if that server has a BMC attached to it. And if you remember from the first slide, that ugly diagram from IPMI, whatever, we talked about that BMCs usually have connection to one of the main buses via PCI or PCI Express. Here's how can you detect if that server has a BMC. You can also use, for example, LS mode, because Ubuntu will detect that this device and that they support it actually by default. You don't need to install anything. And you will see the kernel modules to be able, that it uses to interact via IPMI through the PCI or PCI Express port. And then as an attacker, what you can do is use these tools that the vendor gives you to interact with the BMC. One of the things that you can do, just to show you that it works, is use this tool to query the users on the BMC. And you can see there it's even giving us all the hashes for this user password. In the same way we did this, we could have created a new user on the system. And check that in the command line, there's no password, no kind of authentication. You are just using the tool. The only thing that you need is access. Yeah. So the next thing that we are going to do here is use a feature from the iDRAC that is called shared network or something like that. And basically what it does is uses USB emulation to set up an Ethernet card emulated on the server. So you will have IP communication between the server and the VMC. We will just keep this part of the demo quite fast. Yeah. So basically what I did there was use this feature using this tool called Rakan that Dell gives us that tool. There's nothing there, very fancy. And what we enabled was a network connectivity between the BMC and the server. So once we have network connectivity, we can actually reuse the same exploit that we talked about before, the trick of the LG preload. And what we did here in the video that we just skipped was use that exploit in order to gain a shell on that device. So right now, what we are is here, right? We have from the server, we have compromised the BMC. We were able to jump there. And at this point, you might be thinking, well, I don't care too much because my company has everything patched, so everything is up to date. But even if you have everything up to date, this affects you because using the same tool, you can downgrade the iDRAC to a vulnerable version. And once you downgrade it, then you can use the exact same exploit. So what we did next was we didn't want to stop there. So we had in our lab another server on an isolated network. It was an HP in this case. And that server, the only thing that shared with this other Dell server was that they were both connected to the same management network. So what we did was we did an SSH tunnel on the iDRAC in order to be able to reach the other managed BMC. In this case, it was an ILO. So in the end, what we were able to do was from the internet doing a series of SSH tunnels and having compromised this ILO, this iDRAC, sorry, we were able to reach this BMC that was in a management network, totally unreachable otherwise.
All right. Sorry, but we have only 1 minute and we're almost done. I want to say a couple of things. One of them is persistence. We were able to persist this super easy. There was many ways we can do that. One of them was to try to mess with the firmware, but they decided to do easy way. So when we have access, as Matthias showed, a shell on the iDRAC, we figured out like what things are mounted, and we figured out that the flash was mounted readable and writable. So, and when we started looking around the flash, there was a cron folder. So basically, we just create a cron file there, and you were like every time like you set up the cron, it can connect back to you or like, upload a binary. The interesting thing about that is that it allows you like no matter if you flash the machine, the iDRAC, the cron will continue like that because they don't clean the flash.
Yeah, it survives firmware updates basically.
So no matter how you fix it, your backdoor will be there. So like it's not only interesting from the point, I'm not gonna show the video, the demo, and no to do either. So the point of this is that it's not just like an attack remotely, internally, you can move the direction between the BMC and the server, but also you can just use it as a great backdoor or a ransomware. Like the possibility to do it as a ransomware, compromise the iDRAC, encrypt the disk, and you just keep there, just change the website, and like no matter how much you flash that firmware, you will not be able to get us out of that because you don't have access. You have shared access to that. Not even like they'll have access to that. Anyways, that was the conclusion in like 0 seconds. Blackout probably hate us by now. There's no time for questions. We know we're not going to be no time for questions.
But we will be there in the other room.
There's a room somewhere that we will be around if you have any questions. And other than that, we just want to thank. This was an effort not just by us, but the team. Like we were working together with multiple targets at the same time. So it was not just the two of us. Anyways, thanks a lot for attending.
Thank you, guys.